In this video, we're going to be putting together everything we've learned about area of basic shapes, and we're going to use that to find the area of composite figures. So our essential question is, how do you find the area of a composite figure? Well, a composite figure is a figure that is made up of basic geometric shapes. And when we start combining these shapes that we've talked about, we can form other more complex shapes, and those shapes are called composite figures. So for example, I've got an arrow here that's made up of a triangle and a rectangle. So those two basic geometric shapes come together to form an arrow. Or maybe we have a star shape here, which is composed of a pentagon with triangles attached to it. So all of these more complex shapes are typically composed of basic geometric shapes that we've talked about. So to find the area of a composite figure, basically what we want to do is figure out how to divide the figure into basic shapes. Now, there is not always one right way to do that, so you can kind of use your creativity and imagination to divide the figure into basic shapes that we can find the area of. Then what we want to do is find the area of those basic shapes using the formulas that we've learned, and then add all those areas together. So remember, these are all of the area formulas that we've discussed so far. So we've got areas of circles, semicircles, parallelograms, trapezoids, and triangles. So all of those basic geometric shapes can be put together to form composite figures, but we can still find the areas of them. So let's take a look at this composite figure here. Kind of an odd shape here. Kind of looks like somebody dropped their ice cream cone. So it's made up of two really basic shapes. It's made up of a semicircle and a triangle, if you can see that. So our semicircle is right here, and we need to find the area of that semicircle. So I always start with my formula, so then I can kind of tell what measurements I'm looking for. So the area of a semicircle is 1/2 of pi r squared. So I need to know the radius of my semicircle. Now what I'm given is this whole distance right here, which is the diameter, remember, and we need the radius. So the radius is going to be half of that. So the radius of this circle is 3. So to find the area of the semicircle, I'm going to do 1/2 pi times 3 squared, not 6. I need the radius. So that's going to be 1/2 pi times 9, and 1/2 pi times 9 gives me an area of 14.137 blah, blah, blah. That goes on and on and on. So when that's the case, when we have pi, we're going to have to round. So I'm going to round to the nearest tenth, which would be this place right here. I look to its neighbor. That's below a 5, so that's going to stay 1. So about 14.1 square meters is the area of the semicircle. Now I'm going to add to that the area of my triangle, and my triangle is right here. And recall, to find the area of a triangle, that's 1/2 of the base times height. My base is here, and this 6 meters, this entire distance here, the diameter of the circle, is actually the height of the triangle. So my area is 1/2 of 11 times 6, and 1/2 of 11 times 6 is 33 square meters. So the area of my triangle is 33 square meters. So the area of the entire composite figure together is, I'm going to have to add these together. So when I do that, I get an area of 47.1 square meters. And again, area is always square. The label for that is always square. 47 square meters. So that's how I found the area of this composite figure. Break it down into its basic shapes and then add the areas together. So here, this is an interesting shape. There's a lot of ways actually to find the area of this, and I'm not going to cover all the different ways to find the area of this. But I am going to break this into a trapezoid and a parallelogram. There's actually 2 different ways to cut this into a trapezoid and a parallelogram. So if how you picture it is different, go ahead and try that and see if you get the same answer as I do. We should get the same answer regardless of how we cut this up if we do it correctly. So how I'm thinking is I'm going to cut this shape right here. So what I've created is a trapezoid here on the left, and I've got a parallelogram here on the right. So these are the 2 shapes that I'm going to be finding the area of. So recall, the area of my trapezoid is 1/2 of base 1 plus base 2 times the height. And these 2 parallel sides are going to be my bases So this 13 inches is my base 1, and then this distance right here is my base 2, which is 20 inches, as I could tell from the other side here. So my base 1 and base 2 are 13 and 20 inches. And then I need to know the height, which is the distance between my bases, which is this guy right here. Now I don't know that, it's not labeled, but I know this whole distance right here is 25 inches. And then the shorter distance is 20 inches. So I know that this right here is 25 minus 20, or 5 inches. So you might have to do some arithmetic to figure out some missing measurements if you've cut it in a particular way. So I know my height is 5 inches, and I know my two bases. So now I can calculate the area of my trapezoid. 1/2 13 plus 20 times 5, which is 1/2 of 33 times 5, and 1/2 times 33 times 5 is 82.5 square inches. So my trapezoid is 82.5 square inches. Now I just need to find the area of my parallelogram here, which is a square. It's a 20 by 20 square. So the area is base times height, which is 20 and 20. That gives me an area of 400 square inches for the square. Now I just need to add these two areas together, and that gives me 482.5 square inches for the entire composite figure. Now, if you want to try to cut that in a different way, if you saw it differently, feel free to do that, but you should get 482.5 square inches no matter how you divide it up if you do it correctly. Next one here, we've got a little house-looking shape, and this is a triangle and a parallelogram. I think everybody would agree that that's what you see there. So our top triangle here, I need to know the base and the height here and here. This base is 15 inches. It's going to be the same as the very bottom of the rectangle. So the height is 4 feet, which is shown here. So the area of the triangle is 1/2 of 15 times 4. And 1/2 of 15 times 4 is 30 square feet. Then my parallelogram on the bottom is base times height. So here's the base and here's the height of the rectangle. So the area is going to be 15 times 12, and 15 times 12 is 180 square feet. And then again, I need to add these two together. So 30 square feet plus 180 square feet gives me a total area of 210 square feet. So there's the area of that composite figure there. So finding basic areas and then adding them together. Last one I want to show uses a little different strategy. I'm actually going to use subtraction here, because the way I see this shape right here is one big rectangle with a smaller rectangle cut out of it, if you can see what I mean here. So if I were to draw this right here, this is the big rectangle that I'm thinking of. It looks like a giant rectangle, and then we cut out this part right here, or removed it. So I'm actually not going to add a bunch of areas together. I'm going to find the area of the big rectangle and then subtract this white space here. So take out that space. That's also another perfectly viable strategy to find areas of composite figures if you think of them as removing areas from a larger area. So my large parallelogram is going to be base times height, and the area of that is 42 by 25. So 42 times 25 is 1,050 square meters. Now that's the area of this entire large rectangle that I have outlined in blue. So now what I want to do is find the area of this rectangle inside, and then I'm going to subtract it or take it out or remove it. So the area of that rectangle that's a 22 by 20 rectangle. So 22 times 20 is 440 square meters. So now what I want to do is not add these together, but actually subtract one from the other one. I'm going to take the 440 square meters out of the larger rectangle, and that gives me an area of 610 square meters. So that's the area of all that blue shaded space, is 610 square meters. Now, if you wanted to, you could cut this up into smaller rectangles. Some people might see a rectangle here, a rectangle here, and a rectangle here, but that's finding 3 separate areas and then adding them together. Or maybe you saw the rectangles another way. Maybe you saw like this, one rectangle down here, and then a rectangle here, and a rectangle here. But again, that's 3 different areas that I had to find, and then I'd have to add all 3 of those together. This method right here was a little bit faster because I only had to find 2 areas, 2 rectangles, and then subtract them. So kind of use your creativity to see if you can find the shortest, fastest way to find the area of the composite figure, either by adding smaller areas together or taking away a negative space from a larger shape.